Okay, so now in the next part of this lesson, we're going to go over the quotient rule. So it's called the quotient rule because, yeah, you guessed it, you're going to have a quotient of functions. In other words, a function being divided by another function. And let's use f of x and g of x again. So if we want to find the derivative of this quotient with respect to x, so we want to find f of x over g of x. Remember, this is a symbol for differentiating or the derivative, shorthand. This will just be equal to the derivative of f of x or f prime of x times g of x minus, this time we hold the f as is, minus f of x times g prime of x. Let me fix that. We're not done yet. On the bottom though, we gotta remember that g of x gets something, get some extra action here. And then what happens, it just all over the g of x function squared. So again, if you want to find the derivative of a quotient where we have f of x over g of x, you find the derivative of f of x multiplied by g of x. Then you subtract f of x times the derivative of g of x all over g of x squared. So again, this may look a little confusing, but it's just practice. So let's practice. So that's always, again, the best way to do this. Okay, so we got to find the derivative of each of these functions, and yeah, we got a quotient. So on top here, this is our f. And down here, that's a g. But we want to find the derivative of y. So we want to find y prime. That will be equal to f prime, or the derivative of 5x minus 2, which is 5, multiplied by just g of x. We keep this as is. So x squared plus 1, that's your g f prime. Now from here, we subtract f of x. We subtract f, which is just top, which is 5x minus 2, multiplied. Now it's g's time to get differentiated. So it's multiplied by the derivative of x squared plus 1, or multiplied by 2x, all over g of x squared. So all over the x squared plus 1 squared. Now, I'm just going to warn you right now, maybe not warn you, but let you know that these problems are really action-packed, meaning that you're going to have to do sometimes a lot of simplification, not going to lie. But the good thing is that you're good at that because you're in calculus, which you should have, mastered in, pre-cal or algebra 2. But in any case, you're done with the calculus part at this point. The rest is just algebra, and you want to make it simplified as best as you can. We don't like messy problems as their solutions. So let's combine like terms to see what cancels out. So let's distribute. So we got here, we got a 5x squared plus a 5 minus, distribute that 5x to that 2x, so 10x squared minus 2x, so minus 4x, all over the bottom. Let's just keep it like that. I don't think there's anything more we can do with it for now, at least. Okay, so what we got here, we got a 5x squared minus a 10x squared. So what we got then is a negative 5x squared plus a 5 minus a negative 4x. So plus a 4x, let's keep this in, standard form, or, in order. And let's add that 5 at the end. And all over x squared plus 1. So leave your final answer like this. Can't really simplify this anymore. So you're all good. Okay, now let's look at the next one. Y is equal to x squared plus 3x over 6. All right, so you got a quotient of functions, right? You got your f of x over here. You got your g of x as 6. You got your f over your g. So what you're going to do, you're going to do this, right? You're going to do f prime times g of x minus f of x times g prime of x all over g of x squared. So go ahead, do that. No, you're wondering like, why not? What am I doing? Why aren't I, why didn't I jump to it? Because there's a reason. This can be made simpler or easier to work with if you realize that the denominator is just 6. You can just break this into two fractions being added, meaning this is the same as 1/6 times x squared plus 3/6 times x. And this is much quicker to differentiate, and you don't need the quotient rule for this. Now the quotient rule is fun, but don't worry, you're gonna have plenty of times where you have to use them. So use your time wisely though, because this is just the power rule, and these are just coefficients. So if we take out, if we got y prime, we got 1/6 times 2x. So we got, or 2/6x, or just 1/3 x, plus 3/6x, which is just 1/2, plus 1/2 x. The derivative of 1/2 x is just 1/2. And that's your answer, you're done. So, or this is right, that 2/6 is 1/3 x plus 1/2. So use your time efficiently. Make sure you think think before you jump to rules, because you can save yourself some time and, maybe some painful, tedious stress that's not necessary. Now let's keep on going. See, we got 3 minus 1 over x plus 5. Okay, so over here, don't really see a way we can't avoid the quotient rule. So let's get to it. We got the g as the x plus 5. We got the f as this guy. So y prime will be equal to the derivative of f, which will be 0, minus the derivative of 1 over x. Now to the side over here, remember 1 over x is the same as x to the negative 1. So the derivative of negative 1x, let's keep that negative here because it's 0 minus. Let me just write the 0 actually so we don't get confused. So 0 minus the derivative of x to the negative 1. So 0 minus a negative x to the negative 2 there. That's just your f prime. Keep the g as is, so multiplied by x plus 5. So this is your f. Oh, no, that's your f prime. Excuse me, that's f prime. That's your g. From this, now we subtract. This time we keep the f the same. So let's keep this as 3 minus 1 over x. Let me just keep it as actually 3 minus x to the negative 1. I have a feeling that that's going to be a little easier to work with. Now we take the derivative of g. So multiplied by the derivative of g, which is just going to be 1. So we got our g prime here. And we got our f prime here. All over g squared. So all over the x plus 5 squared. Using our rule, quotient rule. Now we gotta make sure we simplify and do our algebra, but the calculus part is done. So let's be careful here. So we got negative, so we got a positive. So we got a positive x to the negative 2 multiplied by x plus 5. We actually keep that green pen in action. This is our g. And from that, we're subtracting. This just doesn't matter. So minus 3 minus a negative x to the negative 1. So it's basically plus x to the negative 1. All over the x plus 5 squared. All right, let's see what happens next. Okay, so you can see like, okay, we got x is the same as x to the negative 1. So x to the negative 2 times x to the negative 1, adding the exponents becomes x to the negative 1. And then x to the negative 2 times 5 is just 5 x to negative 2 minus 3 plus x to negative 1 all over x plus 5 squared. And so then what you have left is basically 2x to negative 1 plus 5x to negative 2 minus 3. Let me just go over here. What we got is 2x to negative 1 plus 5x to negative 2 minus 3 all over x plus 5 squared. And that's pretty much your answer. I mean, you can go further and further and try to rationalize and find common denominators and flip, but you're not really going to get any much simpler than this. However, some professors want your exponents to always be positive. So just be careful about that, because you know, they're your boss, they're the boss, they're your boss, or you know, so just if it is, just make sure you leave this as 2 over x plus 5 over x squared minus 3. All right, now let's look at what's going on here. So what we got here is, let me separate them. So we're working in here. So we got it. That y is negative 3 times 3x minus 2x squared over 7x. So again, make sure you take a minute to stop and think, should I just jump straight to the quotient rule? Is there something I can do to, you know, make my life a little easier? And there is. Because what you actually have is a negative 3/7. That's really your coefficient. So let's do this. All right, we're just factoring out this negative 3/7 because that negative 3 is being distributed on top. And what do you notice about all the other terms? They all got an x. So you can factor out an x out of the rest of the terms. So all you have left in the bottom here is 1. And here you got 3. And here you just got minus 2x. Whoa. What do you know? All you really have then is negative 3/7 times 3 minus 2x. So then all you really got to take the derivative of is 3 minus 2x. And then once you take that derivative, you just multiply by negative 3/7. So we got negative 3/7 times the derivative of 3 minus 2x, which is just negative 2. That's simple. And then you get a number, 6/7. Strange number. I don't think I've ever seen it other than in this problem, but it's a number nonetheless, so it's possible. So again, think before you jump to the quotient rule. Maybe you don't have to use it, maybe you do got to use it, but practice. So I hope that helps, so good luck.